Example 1, for the function g whose graph is given, so g is this blue stuff. State the value of the given quantity if it exists. If it does not exist, explain why. And I've made a few modifications here. I think they match up to the sheet that's on that you have now, but if not, a few things will be there. Anyway, a couple things. They ask for limits a lot. Limit, limit, limit. They also ask for some functional values. So the difference in those is if it's asking for a limit of g of x as x approaches some number, that equals where the graph's going to. So where is the graph going to? Where is graph going to? If it's just g of a number, it means where's the point? Where is the... by point, the closed circle point, not the open circle point. So functional value, you're looking for an actual point. A limit, you're looking for where the graph's getting close to. That's the difference in the questions. Everything is about the y value. The answer to every one of these questions is a y value if it exists. All right, so the first three kind of have to do with each other. They all involve -2, x approaching -2. So -2 is right here. Purple. All right. And the limit expressions here, x is approaching -2 minus, x is approaching -2 plus, x is approaching -2. All right. The difference in those statements, there we go, is the -2 minus means that I'm starting on the graph. Anytime you do a limit, you start on the graph. And you're going to get closer and closer to x equals -2 from the graph. Minus means starting at a number smaller than -2, so starting from the left, and then getting closer to -2 from the left, so you're going towards x equals -2. And the answer is the y value. So as I get really, really, really close to -2 from the left-hand side, this function is getting really, really close to a height of -1. It obviously doesn't equal -1 because there's an open circle there. It doesn't matter. Okay, limit doesn't matter about what it equals. It matters about what it's getting close to. All right, the same thing here. X approaching -2 plus. That means that we're starting at a number bigger than -2, and we're going to be approaching it from the right-hand side. Again, limit means jump onto the graph, walk along the graph as you get closer and closer to the next value of -2. You're looking for the height of the graph, which is a +1. Okay. So again, the answer is always just what the y value is at the point that they care about. Now, the third one asks for the limit as x approaches -2. Now, we have a left-hand limit and a right-hand limit. That's what these are officially called. If those two numbers are exactly the same number, that's the answer to this question. If they're different, the limit does not exist. The reason why is the left-hand limit does not equal right-hand limit. And I am fine with abbreviations. I know what it means, and you'll know what it means. But the only way a limit can exist is if the left and right-hand limits are the same number. If they are, that's the answer. If they aren't, the answer just does not exist. All right. Now, when it says g of -2, notice g of number means where is the point. So looking, this is an open circle. No, it isn't. That's an open circle. And this is a closed circle, fill-in circle. So when it says g of -2, it's asking where's the closed circle at, and the answer is +1. So that's limits and that's functional value. That's one of the types of problems you're going to be seeing in this section. Looking at E, F, and G, do that in a different color, let's go red. I suppose I should have that go all the way down to D. But anyway, E, F, and G there. Notice x approaches -2 from the left, x approaches, or sorry, 2 from the left, +2 from the left, +2 from the right, and G of 2. Okay, 1, 2, here's 2. All right. So if I'm trying to find the limit of g of x as x approaches 2, again, if I'm trying to find the limit, I jump onto the graph, coming from the left, so I start below 2. I'm getting closer and closer and closer to 2 from the left, and I'm getting closer and closer to the height of +1. If I want to find the limit as x approaches 2 from the right, again, it's a limit, so I jump onto the graph. I'm coming from the right, so I start big, go smaller. As I get closer and closer to the value of 2 for x, I'm getting closer and closer to the height of 2 for y. Doesn't ask me this time, but notice once again the left-hand and right-hand limits are different, so the limit would not exist at 2. Both of those are called jump discontinuities because the graph goes to a point and then jumps somewhere else. So it's called a jump discontinuity. I don't name these things, I just know what they're called. And then when we look at g of 2, again, I've got an open circle here, I've got a closed circle there. Closed circle counts for g of number. Where's the point? The point's right there, so the answer is 2. Okay. It doesn't have to equal either one of these numbers. It does happen to equal that in this case. When we get down to the 0, you'll see. All right, next. X approaches 4 from the right. Now, what I've got going on here, let's see. This is an oscillating function, and going back to 2.1 homework, that was cosine of 10 pi over x, or sine of 10 pi over x, something like that, and it caused the graph to just really go haywire as we got close to 0. That's what's happening here. It's going haywire. As there's no number it's going to. It just keeps on fluttering back and forth between these, like probably 1.5 and 2.5 here, and it's not approaching anything. Okay, that's it does not exist. Does not exist because it's oscillating. That's the only place where a left to right hand limit might not exist, is in an oscillating function. For the most part, they usually exist. But that's how a left to right hand function might not. All right, limit as x approaches 4 from the left. So if I start here and go towards 1, 2, 3, 4, I can see the height of the function is right around 2. So limit as x approaches 4 from left is 2. Once again, would the limit exist at 4? No, it wouldn't, because these aren't the same thing. All right, so moving on to the last one. We're trying to find the limit all around 0. X approaches 0 from the left, 0 from the right, 0 in general, and also g of 0. I'm going to go limits first and functional value last. So if we look at x approaches 0 from the left, I'm here, and I'm going this way. As I get closer and closer to x equals 0 from the left, I'm getting closer and closer to the height of y equals 0. If I'm coming from the right, starting here going towards 0, I'm getting closer and closer to the height also of 0. So the limit as x approaches 0, the left-hand limit equals the right-hand limit, so the answer is 0. But notice the functional value. Where's the point at 0? X equals 0, the point's right here at 1, right? Or negative 1. So g of 0 is negative 1. Once again, the functional value does not have to equal the limit. All right? Most of the problems in the first part of the section are going to be this type. One extra thing that could occur that isn't dealt with there is asymptotes. So suppose we get an x-axis and a y-axis going here. Let's say the graph does something like this. Let's say that's it. In fact, just so that there's no confusion, let's just make that just kind of go like so. All right, there we go. So what we're looking at here is the graph is going here and then it shoots straight up. There it shoots straight down. Here it's shooting straight up. There it's shooting straight up. There it's going off forever, and that's kind of going off forever that way. If they ask me stuff about limits here, so if it says limit as x approaches negative 2 minus, limit as x approaches negative 2 plus. If I'm on the graph here, and I'm getting closer and closer to negative 2, the graph's going up to infinity, so it's a positive infinity. If I'm here, from the right, going this way, it's going down forever, so it's equal to negative infinity. Right? Limit does not exist at x equals 2 because they're not the same. But this right here, if it asks for the equations of the asymptotes, you're going to write x equals negative 2. The equations of asymptotes. X equals negative 2. It's always x equals number. The number is where it is. So 1, 2, 3, 4 is the other one, right? X equals 4. Every single asymptote is x equals number. All right. On this one, the left-hand limit is positive infinity. The right-hand limit is positive infinity. So the overall limit, as x approaches 4, is positive infinity. And one more that popped up a couple times just recently. Suppose I say limit as x approaches 3 of f of x. Let's say this is f of x here. Okay. 1, 2, 3. 0. Right? Because if I'm coming from the left, it's getting close to 0. From the right, it's getting close to 0. Even though there's not an open circle or closed circle, it's a continuous graph there. If it's a continuous graph, the limit is whatever it equals. If it's discontinuous, if there's a break in it, then you got to, that's usually where they ask you limit questions. And sometimes they'll ask you on a continuous section, it's just whatever the answer is. So in this case, 0.